All right, safety pros, if you're in the construction world, fire safety is, it's not just a box to check, right? It's absolutely mission critical. So today, we're diving deep into OSHA 1926 Subpart F. That's the, kind of the Bible of fire protection and prevention on construction sites. And trust me, there's some seriously interesting stuff in here. Did you know that there are rules about how close a heater can be to a tarp, or how you stack materials can actually impact fire risk? We'll unpack all of that and more. Give you the key takeaways to keep your site safe.
Yeah, and what's fascinating to me is that OSHA 1926 Subpart F really goes way beyond just reacting to fires. It's a framework for preventing them in the first place, which is so important, especially in an environment like construction.
Yeah, that makes sense. You've got welding, cutting, temporary heating, not to mention all the flammable materials just sitting around.
Exactly. So the standard starts by laying out the ground rules. In 1926.150, the general requirements, and right off the bat, OSHA puts the responsibility squarely on the employer's shoulders. They need a fire protection program, and that means ensuring that firefighting equipment is readily available wherever those fire hazards pop up.
No passing the buck there.
Yeah.
And just having the equipment isn't enough, right? You got to make sure it actually works.
Absolutely. 1926.150A4 is very clear. Periodic inspection and maintenance for all firefighting equipment. We're talking checking gauges, testing hoses, making sure those extinguishers are charged. Imagine a fire breaks out and your extinguisher doesn't work. You're not just looking at property damage, you're talking potential injuries, even fatalities.
Yeah, that's a powerful point. And a good reminder to stay on top of those inspections. Now, the standard also talks about having a trained fire brigade, especially on larger projects.
Right. 1926.150A5 gives employers some flexibility there. It's not a blanket requirement for every site, but they need to decide if a fire brigade makes sense for them based on the size and complexity of their project.
So, bigger project, more moving parts. Potentially a fire brigade makes sense.
Got it.
Now let's dive into water supply. 1926.150B lays out the requirements there.
This section is all about having those essentials in place. Enough water for long enough and with enough pressure to actually fight a fire effectively. It even gets into the timing of underground water main installation, saying that they should be ready to go as soon as possible.
Yeah, I guess in an emergency, the last thing you want to be doing is searching for a working hydrant or trying to figure that out. All right, let's move on to fire extinguishers and small hose lines. It's a 1926.150 UAC. This seems like one of those areas where a lot of sites might have some gaps.
Yeah, it's definitely where the rubber meets the road. OSHA gets really specific here. They're talking square footage, travel distance. You need at least a 2A extinguisher for every 3,000 square feet. And nobody should have to travel more than 100 feet to grab one.
Yeah, time is of the essence in a fire, so that makes sense. But the standard does offer some alternatives, right?
Exactly. Instead of that 2A extinguisher, you could go with a 55-gallon water drum and 2 fire pails, or a garden-type hose. But it has to meet certain discharge and range requirements.
OSHA's not messing around. And what about multi-story buildings? Anything special there?
Absolutely. 1926.150C1 says each floor needs at least one 2A extinguisher, conveniently located near a stairway. They also address cold weather conditions. You got to protect those extinguishers from freezing. And this is important. If you're working with flammable liquids or gases, you need a 10B extinguisher within 50 feet.
Hold on, why the different rating for flammable liquids and gases?
A 10B extinguisher is specifically designed to handle those flammable liquid fires. And that 50-foot rule, that kicks in as soon as you have more than 5 gallons of flammable liquid, or 5 pounds of flammable gas on site.
Interesting. So pay close attention to what you're working with, folks. It can change the whole game. Now, before we move on, I want to quickly touch on a few other points in 1926.150. There are requirements for fire hose connections, making sure they're compatible with the local fire department. Then we have fixed systems, sprinklers, and standpipes, which need to be operational as soon as legally possible.
Those are critical. You know, sprinklers can often knock down a fire before it really gets going, and standpipes give firefighters quick access to water throughout a building.
A real 1-2 punch for fire safety. The standard also covers fire alarm systems and fire cutoffs during construction and demolition, both key for stopping fires from spreading.
It's like building a multi-layered defense against fire. Each of those elements plays a role in reducing the risk.
Okay, let's shift gears and talk about fire prevention, covered in 1926.151. I'm curious to hear about some of the specific hazards that OSHA calls out here.
Well, this section's all about anticipating those common ignition sources. We're talking electrical wiring and equipment, internal combustion engine exhaust, smoking, Even things like battery-powered lighting.
So many potential sources. It's easy to see how things could go wrong quickly on a site.
Right. Think about a construction site. You've got exposed wiring, sparks from welding, engines running. It's a tinderbox if you're not careful.
Yeah, and that's where these regulations come in. Now, the standard then zeroes in on temporary buildings in 1926.151b and open yard storage in 1926.151c. For temporary buildings, it seems like placement is key. Exits need to be clear. You have to think about fire resistance and distance from other structures.
It's all about limiting that risk of fire spreading from one building to another. And open yard storage, that's where OSHA gets really specific. They tell you how high you can stack combustible materials, how wide your driveways need to be, even how far those stacks need to be from buildings.
So you can't just toss stuff in a pile and call it a day. There's a method to the madness.
Exactly. It's all designed to prevent those fires from starting and spreading in the first place. Remember, an ounce of prevention is worth a pound of cure, especially when it comes to fire. But we've covered a lot in this first section, and there's so much more to the standard.
For sure. But before we move on to flammable liquids, let's take a quick breather and come back refreshed and ready to keep diving deep.
Sounds good. Welcome back to the deep dive. In part one, we tackled some of the general requirements for fire protection and prevention on those construction sites from OSHA 1926 Subpart F.
Yeah, we covered the big picture stuff, having a fire protection program, keeping equipment in top shape, essentials of a water supply. Now, are you ready to roll up your sleeves and get into the nitty-gritty, some specific hazard?
Absolutely. And for anyone dealing with flammable liquids on their sites, this next section is crucial.
You're talking about 1926.152, all about flammable liquids. It's dense, it's detailed, definitely not something you want to skim over.
What's important to understand here is this section goes beyond just storage. It covers those different categories of flammable liquids, dives deep into indoor and outdoor storage, fire control measures, dispensing procedures, even specific requirements for service and refueling areas. We're talking about a comprehensive guide to keeping those flammable liquids under control.
So if you're using flammable liquids on your site, this section is basically your Bible. And it all starts with understanding those categories, right?
Exactly. OSHA breaks flammable liquids down into 4 categories based on their flash points and boiling points. And the lower the flash point, the easier that liquid can ignite. So the stricter those regulations become.
So Category 1 liquids, with flash points below 73.4 degrees Fahrenheit, those are the most volatile, requiring the most stringent precautions. Things like gasoline, acetone, certain types of paints and adhesives.
Precisely. And as you move up through the categories, the regulations become slightly less stringent, but they're still there for a reason. Even those Category 4 liquids, with flash points above 140 degrees Fahrenheit, can still pose a significant fire hazard under the right conditions.
Okay, so let's say you've got those Category 1 liquids on your site. What kind of specific storage regulations are we talking about? Walk me through it.
All right, so if you're storing them indoors, you can't have more than 25 gallons outside an approved storage cabinet. And these cabinets have to meet very specific requirements. They're either metal or made from a very particular type of fire-resistant plywood that's been rigorously tested.
So not just any old cabinet will do, right?
Right.
It's got to be the real deal. And what if you've got more than 25 gallons?
Then you need a dedicated inside storage room. For anything over 60 gallons of Category 1 liquids, it needs to meet those strict fire-resistant standards and ventilation requirements.
Dedicated space, properly ventilated, makes sense. Anything else we need to know about those indoor storage rooms?
Yeah, absolutely. 1926.152b4 has a crucial detail. Those rooms can't contain any materials that could react with water and create a fire hazard. So no mixing incompatible chemicals. It's about minimizing those potential chain reactions.
That's good to know. You definitely don't want to create an even bigger problem if a fire does break out.
Yeah.
Okay, so we've talked about indoor storage, but what about storing those flammable liquids outside? What does OSHA have to say about that?
For outdoor storage, the standard gets equally specific. You have limits on the size of the containers, how much you can store in a single pile, and you have those mandatory clearances between piles. And from buildings, so imagine you're working on a site, with multiple outdoor storage areas for flammable liquids, you've got to think about how those areas are laid out, how far apart those piles are, and how far away they are from any structures.
So it's not just about keeping them away from buildings. You've got to factor in the spacing between those piles, too. Makes sense. What about those portable tanks?
If you're using portable tanks, the standard dictates their placement, their capacity, even the types of emergency venting, and other safety devices they need. For example, those tanks need pressure relief valves. And those valves need to vent to a safe location, not near building openings.
It's like OSHA has thought of every possible scenario to prevent a fire from those flammable liquids. Even the drainage and diking around those outdoor storage areas is meticulously regulated. To contain spills and keep those liquids away from ignition sources, it really highlights how even a small spill could lead to a major incident if you're not careful.
Exactly. It's about minimizing those ignition risks at every step of the process. And that brings us to fire control measures. For flammable liquid storage, this is where those 20B fire extinguishers come in.
Now you're talking my language. Let's dive into those fire extinguishers.
Okay, so they're mandatory for both indoor storage rooms and outdoor storage areas, and they need to be strategically placed. For quick access, think about it. In a fire, every second counts, so you need to make sure that those extinguishers are easily accessible and that everyone on site knows where they are and how to use them.
That's crucial. Knowing your way around a fire extinguisher could be the difference between a small incident and a major disaster. Now, what about those tank trucks or vehicles used to transport and dispense flammable liquids?
Well, they need a 20BC extinguisher on board at all times, because if a spill or a fire happens during transport, you need to be ready to act immediately. Imagine a tanker truck pulling up to your site to deliver fuel. That truck needs to have the right fire extinguisher on board, just in case.
Okay, we've talked about storage and fire control. Let's get into the actual dispensing of those flammable liquids. What kind of safeguards does the standard put in place for that?
This is where things get even more interesting, because the standard recognizes that dispensing is a high-risk activity. For starters, if you're transferring more than 5 gallons of flammable liquid from one container to another, that transfer area needs to be isolated, either by distance or a fire-resistant barrier. You also need adequate ventilation to keep those flammable vapors in check.
So you're saying if I'm transferring fuel from a drum to a smaller container, I need to be thinking about isolating that operation, making sure that area is properly ventilated.
Exactly. And it's not just about where you do it, it's about how you do it. For category 1, 2, and 3 liquids, the containers need to be electrically interconnected and bonded during transfer to prevent static sparks. And forget about using air pressure. That's strictly prohibited because it could cause an explosion.
Yeah, I can see how that would be a recipe for disaster. So it's all about minimizing those ignition risks at every step of the process. What about when you're actually using those flammable liquids? Are there any specific precautions there?
Even at the point of final use, there are precautions. Those category 1, 2, and 3 liquids need to be kept in closed containers when they're not actively being used. Any spills need to be cleaned up promptly and safely. You can't just leave a puddle of gasoline to evaporate on its own, and you can only use those more volatile flammable liquids in areas where there are no open flames or other ignition sources within 50 feet. And that 50-foot rule might even need to be extended, depending on the conditions of the site.
So let's say you're using a flammable solvent for cleaning. You need to keep that solvent in a closed container when you're not using it. Clean up spills right away and make sure there are no ignition sources nearby. And that 50-foot rule, that seems pretty important. What are some practical considerations for that on a construction site?
Think about where you're storing and dispensing those flammable liquids, where those ignition sources might be. Things like welding operations, temporary heating devices, even running engines. You need to maintain that safe distance to prevent those vapors from reaching an ignition source. And remember, wind can carry those vapors a surprising distance, so you might need to adjust that buffer zone depending on the weather conditions.
That's a really good point. Wind can definitely change the game when you're dealing with flammable vapors. Okay, so we've covered storage, dispensing, and even use. What about those service and refueling areas? It seems like those would present some unique challenges.
You're right, those areas bring their own set of hazards. Think about it. You've got vehicles being refueled, engines running, potential fuel spills. It's a recipe for disaster if you don't have the right safeguards in place.
So what kind of specific regulations apply to those areas? I'm curious to hear how OSHA tackles those challenges.
Well, first of all, those flammable liquids have to be stored properly, either in approved closed containers, underground tanks, or above-ground portable tanks. And those tanks need to meet the same stringent requirements we discussed earlier, like those pressure relief valves and proper venting.
Makes sense. You're essentially bringing all those storage and handling regulations we've been talking about and applying them to this specific area. What about fire protection? Are there any specific requirements for service and refueling areas?
You've got to have readily accessible switches to shut off power to all dispensing devices in an emergency, because time is of the essence in a fire. And you need to be able to cut off that fuel supply quickly And those switches. They need to be located away from the dispensing devices so someone isn't trapped near a fire if they need to hit that kill switch.
That's smart. Thinking about not just controlling the fire, but also providing a safe way to shut down the fuel source. And of course, no smoking or open flames anywhere near those service and refueling areas.
Absolutely, that should go without saying. But the standard makes it explicit. And those no smoking signs, they need to be clear, conspicuous, and impossible to miss. Think about using multiple signs, different sizes, maybe even different languages, if you have workers who speak different languages on site.
That's a good point. Clear communication is key.
Yep.
Especially when it comes to safety. Okay, so we've covered a lot of ground on flammable liquids. There's one more piece of the puzzle I want to explore before we wrap up this section. The installation, testing, and maintenance of tanks used to store those liquids.
That's covered in some serious detail. In sections 1926.152 high through 1926.152K, we're talking everything, from the materials and construction of those tanks to the specifics of their installation, venting, even protection against corrosion and earthquakes. It's like a whole engineering course.
Yeah.
Crammed into a few pages of OSHA regulations?
Wow, that's intense. But I guess it highlights how important it is to get those installations right. A poorly installed or maintained tank is a ticking time bomb. Yeah, so for our listeners who might be feeling overwhelmed by all these details, let's break it down into a few key takeaways.
Good idea. First of all, the type of tank construction and installation really depends on whether it's above ground, underground, or inside a building, and each location has its own set of challenges and regulations.
Right. So, for example, an underground tank needs to be protected against corrosion and potential damage from things like traffic or flooding. And an above-ground tank has those strict spacing requirements and needs those emergency venting systems. To relieve pressure in case of a fire, it's about tailoring those safety measures to the specific risks of each location.
Exactly. And regardless of the tank's location, there are stringent requirements for venting. The standard gets very specific about vent pipe sizes, placement, even the use of flame arresters to prevent those flammable vapors from igniting. And don't forget about drainage and diking. Those are crucial for containing spills and preventing those flammable liquids from spreading.
So you're saying that even if a tank is installed perfectly, you still need those backup systems in place to manage spills and prevent those vapors from reaching an ignition source. Now, before we move on, I want to touch on one last point, tank testing. Because it's not enough to just install a tank and hope for the best, right?
Right. The standard requires rigorous testing to ensure that those tanks are structurally sound and leak-free. And that testing has to be done before the tank is put into service and after any repairs. We're talking about hydrostatic testing, pneumatic testing, even leak testing using air, inert gas, or water. It's about being 100% certain that those tanks are up to the task of safely containing those flammable liquids.
It sounds like OSHA really wants to make sure those tanks are built to last and won't let those flammable liquids escape. Okay, so we've covered a lot of ground on flammable liquids in this section, but there's still more to explore in OSHA 1926 Subpart F.
In the next section, we'll shift our focus from flammable liquids to another common hazard on construction sites, liquefied petroleum gas, or LPG. Stay tuned. It's going to be a fascinating deep dive.
Welcome back to the final part of our deep dive into OSHA 1926 Subpart F. We've covered a lot, from those general fire safety requirements to the specifics of flammable liquids. And now we're tackling a substance that deserves a whole lot of respect. Liquefied petroleum gas, or LPG as most people know it.
Yeah, LPG is a fantastic fuel source. It's efficient, portable, versatile, but its very nature presents some unique hazards, and that's where OSHA 1926.153 comes in. This section really lays out the ground rules for using LPG safely on construction sites, and it all starts with the equipment.
Okay, so you're saying we can't just grab any old propane tank and hose from the hardware store?
Exactly. 1926.153A is crystal clear. Everything, containers, valves, connectors, manifolds, regulators, must be of an approved type. We're talking about equipment that's been specifically designed and tested for LPG service, meeting those stringent safety standards. You can't just cobble together a system from random parts and hope for the best.
No cutting corners when it comes to LPG. And speaking of things you shouldn't do with LPG containers, welding is a big no-no, right?
Absolutely. 1926.153B puts it simply, no welding on containers. That risk of igniting trapped gas or weakening the container's integrity, it's just too high.
So if repairs are needed, you're looking at replacing the container entirely.
Better safe than sorry when it comes to LPG. Now let's zoom in on some of those critical safety features, starting with valves and accessories.
Okay, let's talk valves. What do we need to know to keep those LPG containers under control?
1926.153C gets into the details there, emphasizing that anything connected directly to the container, including those primary shutoff valves, needs a minimum working pressure rating of 250 PSCs, and they have to be made of materials that can handle the unique properties of LPG.
Okay, I'm going to stop you there for a second. For those of us who aren't engineers, what exactly is PSI? I know it's a pressure rating, but what does it actually mean?
Great question. PSIG stands for pounds per square inch gauge. It's a way to measure pressure relative to atmospheric pressure. So 250 PSI means the pressure inside that container is 250 pounds per square inch higher than the air pressure around it.
So those valves and connectors need to be able to handle that kind of pressure without failing. Makes sense. Anything else we need to know about the valves?
The standard also mandates shutoff valves as close as possible to the container on all other connections. The only exceptions are safety relief connections and a few other specific cases. It's all about being able to isolate the container quickly if there's a problem.
So it's like having multiple layers of control, making sure you can shut off the flow of LPG at various points in the system. That's a good safety practice for any hazardous material, really.
Absolutely. And speaking of safety, let's talk about those all-important safety devices. Covered in 1926.153D, every LPG container and vaporizer needs at least one approved safety relief valve or device. These things are crucial. They prevent dangerous overpressure situations.
I've seen those pressure relief valves on propane tanks before. Usually a little brass fitting on the top. They're kind of small, but they play a big role. What do we need to know about them?
First of all, they have to be properly sized and installed to handle the pressure of the system. And there are rules about where those relief valves can vent. It can't be anywhere near a building opening. That's below the discharge point.
So you can't have those gases venting right into a window or a doorway. That makes sense. You don't want those flammable vapors accumulating near a potential ignition source.
Exactly. And here's another crucial detail. You can't install a shutoff valve between the safety relief device and the container or the equipment it's connected to. The only exception is if that valve is specifically designed to allow full flow capacity through the relief device, even when it's closed. You never want to compromise that safety pathway.
It sounds like OSHA is really emphasizing the importance of those safety relief devices, of the last line of defense against a catastrophic overpressure event.
Okay, so we've talked about the containers themselves, the valves, the safety devices. Now let's get into the actual handling of LPG. What does the standard say about dispensing those containers?
1926.153E lays out the rules for dispensing LPG. This is where those mandatory distances from buildings come into play. If you're filling fuel containers for trucks or vehicles, from a bulk storage container, you need at least a 10-foot buffer from any masonry-walled building, or 25 feet from any other building or building opening.
So no refueling right next to the job site trailer.
Got it.
Yeah.
And what about filling those smaller portable containers?
If you're filling portable containers, that safe distance jumps up to 50 feet from any building.
So it's like a sliding scale of precaution based on the size of the container and the amount of LPG you're handling. Makes sense. Now let's say I've got some LPG-powered equipment on site, things like heaters, generators, maybe some forklifts. Are there any specific requirements for using those appliances?
Absolutely. 1926.153 prefets some clear expectations there. For using LPG appliances on construction sites, first and foremost, those appliances need to be approved types, meaning they've been designed and tested specifically for LPG use. You can't just grab any old appliance that runs on natural gas or propane and assume it's safe to use with LPG.
I guess it's like using the right tool for the job. You wouldn't use a hammer to drive a screw. And you shouldn't use an appliance that's not designed for LPG. What if I have an appliance that was originally designed for a different type of gas? Can I convert it to run on LPG?
It needs to be properly converted, adapted and tested for LPG compatibility before you even think about firing it up. And that conversion work should be done by a qualified professional who understands the risks and knows how to do it safely.
Okay, so approved equipment, no welding on containers, safety devices in place, careful dispensing. Now let's talk about actually storing those LPG containers.
When it comes to storage, we need to make a clear distinction between containers used inside buildings and those stored outside. Let's start with those outdoor containers covered in 1926.153G and K. They need to be upright, secured on a firm foundation, and protected from potential damage.
So no leaning them against a wall or leaving them lying on their side.
Definitely not. And the placement of those containers, it's all about distance. And those safety buffers increase based on the amount of LPG being stored.
Okay, walk me through that. How far away do those containers need to be from buildings?
For containers holding 500 pounds or less of LPG, there's no minimum distance requirement. But as you go up in weight, those distances increase, all the way up to 25 feet, for anything over 10,000 pounds.
It's like those increasing setbacks you see for larger buildings. The bigger the hazard, the bigger the buffer zone. And I imagine those outdoor storage areas need to have fire protection too.
Absolutely. You need at least one 20 BC fire extinguisher readily available in those outdoor storage areas.
Okay, so outdoor storage is all about distance and fire extinguishers. Now, what about using LPG containers inside buildings? Is that allowed?
1926.153 lays down the law on that one. The general rule is that storing LPG inside buildings is a no-go, but the standard recognizes that there are times when you might need to use containers inside for operational purposes. So it lays out some very specific conditions that have to be met.
So it's not an outright ban, but there are some strict hoops to jump through. If you need to use LPG inside, what are some of those requirements?
For starters, you need those excess flow valves on containers larger than 2.5 pounds. These valves are designed to automatically shut off gas flow if there's a rupture in the line, preventing a major leak. And the regulators have to be directly connected to the container valves or manifolds and be designed for at least 250 PSIG service pressure.
Okay, so we're back to that pressure rating again. So those regulators are essentially acting like pressure reducers, making sure the gas is delivered at a safe pressure. To the appliances, what about the piping and hoses used to connect those containers to the appliances? Any special requirements there?
The materials matter. You can't use aluminum piping or tubing, and those hoses need to be approved types, specifically designed for LPG service. They also have to be short enough to avoid kinking or damage from heat, but long enough to maintain those safe distances from ignition sources.
It's like finding that Goldilocks zone. Not too short, not too long, just right. Now, what about those portable heaters, those salamanders we talked about earlier? Are there any special rules for using those with LPG indoors?
Good question. 1926.153H is very specific about that. If you're using one with an LPG container inside, that container can't be any larger than 2.5 pounds, and there are restrictions on how close other types of LPG heaters can be to containers, especially those blower and radiant types. That can throw heat a considerable distance.
So it's about using the heater effectively, but maintaining those safety buffers to prevent the heat from the heater.
From affecting the container. Now, what about those multi-container systems? Sometimes you see those on construction sites with multiple propane tanks connected together to supply larger appliances. Are there any special considerations for those?
1926.153I steps in with a requirement for that. For those multi-container systems, the valves have to be arranged so you can swap out containers without interrupting gas flow to the system. It's about minimizing downtime, but doing it safely, without compromising the integrity of the system. And those multi-container setups, whether for heaters or other purposes, have their own spacing requirements, both between the manifolds themselves and between the containers connected to a single manifold. So it's not just about keeping those containers away from buildings. It's about spacing them out from each other to prevent a chain reaction if one of them fails. And finally, if you're dealing with LPG and other gases in the same area, 1926.153 has a simple but crucial requirement: clear labeling.
Right. You need to be able to identify the contents of each container quickly and easily. Think about color coding the containers or using those standard markings that everyone in the industry recognizes. It's all about preventing those dangerous mix-ups. Imagine a worker grabbing the wrong container. The consequences could be disastrous.
Absolutely. Clear labeling is essential when you're dealing with any kind of hazardous material. Okay, we covered a lot of ground on LPG in this section, and I think the key takeaway is that it's a substance that demands respect. Every aspect of its use, from the equipment to the storage to the handling, is regulated for a reason.
And those regulations are based on years of experience, research, and sometimes, sadly, lessons learned from accidents. The goal is to prevent those accidents from happening again.
So whether you're a seasoned safety pro or just starting out in the construction industry, take the time to really understand these LPG regulations and make sure they're being followed on your job sites. It's about protecting lives, preventing injuries, and keeping those projects moving forward safely.
Well said. And that brings us to the end of our deep dive. Into OSHA 1926 Subpart F, we covered a lot. From general fire safety principles to the specifics of flammable liquids and LPG. But truly effective fire safety goes beyond just checking boxes and following the letter of the law.
It's about developing that proactive mindset, anticipating those risks, and going above and beyond to create a culture of safety on your construction sites.
So as you head back out to your job sites, ask yourself, what am I doing to identify and mitigate those potential fire hazards, even if they're not explicitly spelled out in the OSHA standard.
Because at the end of the day, it's not just about compliance. It's about sending everyone home safe. At the end of the shift.
Thanks for joining us for this deep dive into construction site fire safety. Presented by Safety One Source, your partner in building a safer, more informed construction industry.